Yo, what up, y'all? Welcome back. In this video, we're going to revisit the linear equation we solved in video 12. We're going to solve it again using an algebraic technique, but this time we're going to apply inverses in a different order. Here's the problem statement we're going to focus on this time. Let's read the entire problem out loud for ourselves. Resolve the equation 3 times quantity 2 minus x n quantity equals -8 plus 1/2 times x. We're going to solve this using an algebraic technique. However, this time, let's try to solve this equation in a different way than we did in problem 3a. We immediately recall that to find the solution of an algebraic equation using an algebraic technique, we're going to isolate the variable using inverse operations, of course. Get the variable on one side by itself, a value on the other side so that it is in the form of solution. Remember that each inverse we apply depends on the equation type we solve. Now that we've read our entire problem and we recalled the idea of an algebraic technique, we're going to ask ourselves the same question we ask ourselves always. In this math statement, is there an equal sign? Well, yes, there is. Here's the equal sign. Thus, we know immediately this is an equation, and we're going to solve it. Moreover, because we've seen this equation previously, we know that it is a linear equation. Now that we've determined what we're going to do to this particular bit of math, which is to solve the linear equation, let's start with our first step, which is to rewrite the original equation in our own handwriting. Remember, you are the best mathematician in the world for you. There's no one better, cooler, smarter, more capable. You are just so amazing. Once I've rewritten the original equation, I'm going to create an equivalent equation using mathematical properties. First thing I see is I have multiplication over subtraction. We've seen this many times before. We can distribute 6 minus 3 times x. Here, this addition can be written in any order, and in particular, I'm going to rewrite it like this. The reason that I want to put the 1/2 in front is fractions give me a headache. I've made so many mistakes dealing with fractions in my mathematical career that one of my favorite things to do is to annihilate them, to get rid of them as quickly as possible. Thus, I'm setting myself up in this situation to be able to try to get rid of that silly 2 right there and not have to worry about dealing with denominators. One of the first things I see on the right-hand side is if I were to multiply the entire right-hand side by 2, that would get rid of this particular denominator. But this is an equal sign. Anything I do to the right-hand side, I must also do to the left-hand side. In this situation, I can distribute the 2 times 1/2 times x minus 2 times 8. Over here, I can distribute the 2 as well. This is 2 times 6 minus 2 times 3 times x. We see that 2 times 1/2, that's equivalent to multiplication of fractions. We have this very, very famous property that we'll return to later in the course, which is if I multiply two fractions together, a over b times c over d, I can actually multiply the numerators and multiply the denominators. In this situation, what that means is if I have 2 divided by 1 times 1 divided by 2, that's 2 times 1 over 1 times 2, which is 2 over 2, but 2 over 2 is 1. That entire fraction goes to the number 1. So here I've got 1 times x, 2 times 8 is 16, 2 times 6 is 12, 2 times 3 is 6. Here I'm running out of room. What a rookie does when he runs out of room or she runs out of room is to write really, really small on the bottom, crooked up here, but I ain't no rookie. I'm a pro, right? Best way to keep going when I am running out of room is to grab a brand new sheet of paper and keep the fun rolling. Now that we're here, the next step is to get the x's by themselves. I could either bring this x on this side or this -6 over to the other side. I like to annihilate negatives in case you haven't noticed. So I'm going to do the opposite of subtraction is addition. I add on this side, which means I must add on the other side. So now I have 12 plus 0 because -6x plus 6x is 0. These two things cancel out, and we usually don't write the 0 because 0 plus 12 is always 12. Over here I've got x plus 6x. If I take 1 of something and then add 6 more of that same thing, I must have a total of 7. The x is not by itself. We've got this stinking 16 over here. One of the first things we might do is actually get the 16 over to the other side by doing the inverse operation of subtraction. Negative 16 plus 16 is 0. Since I'm adding 0, it doesn't change anything. 12 plus 16 looks something like 28. So now I've got the equation 28 equals 7 times x. I want to get rid of that multiplication to get the x by itself. The inverse of multiplication is division. If I divide on the right-hand side, I must also divide on the left-hand side. We know immediately 7 divided by 7 is 1. 28 divided by 7 is 4. This implies that x is equal to 4. Of course, I should always check my work, but the whole point of this problem was to confirm that the work that we did in video 12 was legit. And indeed, this is the same answer we got. In this case, we did it with a different method. Now that we've had some practice solving algebraic equations, I want to develop an overview of the strategy I'm going to encourage you to adopt. Anytime we solve a math problem in this class, I'm going to encourage you and me and each of us to do the following steps. The first thing that we're going to do when we're solving math problems is to read the problem statement carefully. Read the problem out loud to ourselves. Read every word slowly. You'll notice that I'm modeling that in these videos. If I had $1 for every time a student made a mistake because they didn't read the problem, I could buy one of you, I don't know, maybe a Tesla, one of those nice SUVs, or I could buy you an entire education at Stanford. I've seen this mistake so often it's not even funny. It's kind of painful, in fact. Thus, I'm going to encourage you, every time you're working on a problem, read the entire problem carefully. The next thing that we're going to do, every time we see math symbols, you'll know when you see math symbols because if you're anything like me, you feel like you got hit in the face with something, right? When you see a bunch of math symbols on the page, in this class, I'm going to say, ask yourself one question. Is there an equal sign in this statement? If yes, then we're going to solve the equation. In our situation, we have one of two techniques. We can either solve an equation algebraically or graphically. When we solve our equation, the final solution is going to be in the form variable equals value. Variable by itself on one side of the solution, some value on the other side. Once we have this solution, we can check our work by substituting this value for the variable back into the original equation and making sure that the left-hand side equals the right-hand side, and this produces a true statement. Thus, every time we solve an equation, at the end of the day, we're going to check our work. If we do well, we're going to drop that mic by putting a box and a little check, because you know our steez. On the other hand, if there is not an equal sign in our statement, we're going to simplify the expression that we're working with. When we simplify, we're going to use the rules of algebra to make the expression as beautiful and simple as possible. Think, math hurts. What we want to do is make it hurt as little as we can. You'll notice that this process I try to follow in every single video where I'm solving a problem. I will try to model this for you as a team so that you can get a sense of how this works. Throughout this class as we solve problems, please revisit this, and I will as well, so that we have the largest chance of showing just how good at math you are. You're hella good at math, you know that? Alright, I'll see you in the next video.